I think, it just seems like maybe we need a little review of Docker, and then how you generally go about navigating a code base that has Docker inside of it. So if we open up this code base, what you can see, this manage.py is essentially what kicks everything off, I think, right? So you can see there's this command, which is save as JSON, right? And this is like the main function that you want to run. How do you know that? Like, how would you know that if, I didn't tell you? Well, in the Docker file, right, you can see it here, right? Python 3 manage.py save as JSON. All right, so this is called like the entry point. Oftentimes, like, this is what kicks everything off. And so what this is doing is it's just running this, right? Python 3 manage.py save as JSON. So if you take a look at we can delete this. What that does, all right, so it does manage.py. It uses this click library, which allows you just to call functions from the command line. So you can do something like Python 3, if we're inside here. It's going to like scraper. Do Python 3 manage.py, call save as JSON, and it will look for this function, or, this name, and then run the function underneath, right? It's like it's a decorator. So just like the same way that we hit a route and it runs the function underneath, that's what this is doing, So then it's going to run this function, save to JSON, and we can click that. And what does that do? Well, that runs the run function. It seems like it gets back a list of positions, and then we open up this data/data.json file, and we'll, for every position in the list of positions, add the dictionary. This is probably a list of instances. So we turn each instance into a dictionary and then write that to the data.json file. All right, so that's what's happening, I believe. All right, so just to go through that again, right, we start at the Docker file. You can see, okay, what is this whole purpose? Like, what the whole purpose of generally like a Docker container is to run this task at the end. So in this case, that's the save as JSON task, and that's in the manage.py file. So then we can go there, see that all that function does is run this save to JSON function. Where does that come from? Index. So now we can go to index. And now what does that do? That calls this run function. Let's dig a little deeper into the run function. So the run function, I don't see, it's up here, right? So normally I just do command click in order to find where it is. So it's just right up there. That calls this get job cards, right? Which I guess returns a list of cards. And then for each card in the list of cards, it calls this indeed adapter, which I'm guessing, takes some messy data and returns like a clean instance, right? So that's these position infos. And then we get a list of them right back here. So we call run, goes through here, returns a list of instances, and then we can go through each of those instances, turn it into a dictionary, and write it to JSON, okay? So we can try that. We can just see, does that actually occur? Let's make sure, so this folder is empty now, and then I'll just run this and wait. Okay, and now you can see the result, right? Data.json results in these list of dictionaries. And remember, like, other techniques for like understanding the code base would be put a breakpoint in, right? Like, let's try that. So let's go to save to JSON. Let's put a breakpoint here, and then just again call it, and just like confirm what we think, So just look at stuff. So hopefully here we're right here. We can look at what is positions. So positions is a list of instances, right? Just like we thought. And then you can maybe look at one of them. We can say, okay, this makes sense. Right, it's pulling out this information. Oh, it's a little off actually, right? Because I don't know, there is a bug here. I don't think we're going to go debug it right now. But you can see that the city is somehow off. Probably somewhere along the lines, it seems like there's a mismatch, but it's okay. Yeah, we just switched the city and the company name, it looks like. All right, so we'll keep going though. So all right, so we ran it locally, right? We can delete this file. The next step would be to build the image. I guess we can do that. So this is, I'm not quite, the only thing I don't know of is where the code's supposed to be. But what we should do is copy this, basically what we need for this directory. So the Docker file, if you look at it, is right here, outside. So what we can do, right, if we're going to do docker build -t and then this Docker file, what we should do is copy, first generally you copy the requirements.txt file. So we do copy scraper, and say /scraper/requirements.txt into the current working directory, right? The working directory in the image. Then we can copy, and then we can build it, right? Like then we can do run pip3 install -r requirements.txt, and then from there we can copy the rest of the code base. So we'll copy /scraper/ into /scraper. All right, so the slash here, I think you need this in order to copy like the files inside, but I'm not, we'd have to look. The reason why I'm doing this is because installing the libraries generally takes a minute. So if I install them and then let's say we update the code base and we make a change, we won't have to rebuild these layers, right? Docker will cache this. I'm not sure, I haven't tried this before class, so I'm not sure if it will work, but let's try it. Let's call this my scraper indeed, and this is my build context. Let me make sure. Okay, so that seemed to be right. Docker build -t. So that's the name of the tag. That's what we want to call the image. We'll call this scraper indeed dot. All right, so that's our build context, and Docker's not running. So that's one. Right, you can see, is Docker daemon running? It's not. So this will just take a minute. And I'm just going to wait till I stop seeing this thing move, and that will tell me that it's up and running. All right, so that looks good. Let's try this again. So it's building. Actually, that went pretty smoothly. We can see, okay, we're using this Playwright thing as a base image. That installs like our scraper software. And remember, the reason why we're using Playwright is because it is hard to Dockerize a scraper. Like just having that Chrome, like the Chrome browser installed inside a Docker image is tricky. So anyway, so we're using this technology called Playwright. And then what are we doing? We're changing the working directory to this PW user. We're copying the scraper requirements.txt file into that directory. We are running the requirements.txt, and then it seems like we're copying the rest. How would I check to make sure this did what I wanted? Let's do docker run -it, the name of the instance, and then bash, right? So we'll bash into it, and we'll just look. So there's my requirements.txt file. That's kind of interesting. It's all right. And then we'll cd into scraper, and there's the rest of my code, okay? From here, if you look at it, right, there is nothing in my data folder. So you can try to run, like just make sure manage.py still works from here, right? So I can say python 3 manage.py, right? This is the same command we'll run automatically in a second, and then save as JSON. But let's just make sure, does this still work, right? Because as we know, when we move inside of a Docker container, like these drivers can get messed up. So okay, so we just ran it, and now if I look at the data, that looks right, and I can even cat the data/data.json, and everything looks good there, right? It seems to be doing that. So right, our process with Docker was first run this without Docker, just make sure our code works, understand it. Next step, build our Docker image, bash into our Docker image, make sure everything still works there. And now that we did that, it doesn't really matter, but, we could remove the data.json. Remember, with a container, once we exit out of the container, that file will nothing will be saved anyway. So we're good. And now what we should be able to do is just run this. So we can do docker run, and just the name of the image, I forget what I called it. Oh, Indeed Scraper. Okay, so what will this do? If I just do docker run scraper Indeed, that will, basically run this command. Okay, and that will produce this data.json file in this folder. And all I want to do is save it to my local directory, to my host computer, right? Because I want to actually get that JSON back. So how do I get something that's going to be in this folder inside my Docker container? We're going to have to bind mount, I believe, right? So I'll do docker run, right? I'll do docker run -v and say in the present working directory, link probably this /home /pw user /scraper /data. Connect that folder in the container to my present working directory. And so when I run this, scraper Indeed will run python3 manage.py save as JSON. That will store the JSON in the container. That will store it in this /data folder, and then we'll port the contents of this folder into the present working directory. Okay, so let's just see if that works. So press return, and I broke it. I probably have this. It seems like I have this wrong. Cannot open file home pw user manage.py. That's not what I put here, but okay. Maybe what's going on, like where is manage.py coming from? I guess it's coming from this, right? So it feels like we could change the working directory to be. Did you guys get the error? Right? It's saying can open file home pw user manage.py. And my question is, okay, how am I even? Who cares about manage.py? Because this thing's not even asking for it. So the guy who cares about manage.py is this right here. Okay. So what I'm guessing, we can try it again. Let's delete this and make it a little simpler. We'll probably see the same error message. Is that I'm in the wrong directory when I'm calling this. See that we should see the same error message. See, there we go again. So instead of calling home pw user manage.py, we want to call scrape home pw user scraper. So we can do, we can just cd, and probably the easiest way is cd into scraper, rebuild the image. We could do that, or we could maybe do this, like run python3 /. Maybe let's try that first. I'm not sure if it will work or not, but I have to rebuild the image. Actually, either way. Sorry. So let's do it this way. This one, I feel better about this. All right. So we'll change the working directory to be this scraper thing, and then we'll run manage.py. Right. That way we'll be inside this folder when we run manage.py. All right. So we have to rebuild the image because we made a change to our Docker file, or actually to anything in the image. We'd have to rebuild it. So we'll do docker build. Look, everything, it was super fast because we've already done these steps and it just cached them. And the only thing it really needed to change was this thing, right? You can see cache. Anyway, let's try to run this again. See if we get the same error. All right, we're not getting, it feels like so far we're not getting the same error. Let's see if it actually completes. It's not the best. I don't know why it's taking this long. I'm surprised. Oh, it finished. Okay. So it finished. What it did not do was ever was actually give me any data here, right? There's no data. So we have to go to the next step, which is let's port the data to my local directory, right? So we're bind mounting the data folder to the local directory. And then when we do the standard Docker run scraper indeed, it will run this command, which seems to have worked. And then it should give me back the JSON. We'll see. All right, let's take a look. There it is. All right, so this is now on my local computer. You can see here's the JSON. So again, what happened was, we did Docker run. We said we're going to bind mount what winds up in this data folder to my present working directory on my computer. And when we do Docker run -it, bash, the first thing that this thing does is it does Python 3 manage.py save as JSON, which will run our scraper and store data in here, right? And then ultimately we mapped that data folder to my present working directory in Docker. All right, so that's everything. Like, what did we really have to do? We just had to build the image and then just run this command that kicked off my process, this Docker entry point, and then save the data in this folder, and then bind mounted this folder to my present working directory. How does that feel? Or questions about that?
This is just a stupid question, but if we use the Boto 3 that you were showing us, we can kind of eventually stop using this type of stuff, right? Like we can just save stuff to there. It seems a little bit easier to me. I don't know.
Stop using Docker, you mean?
Like we can start using the volumes to save stuff locally, right?
That's true. Yes, we can stop saving. So that's a great point. Yeah, ideally, right? We have the data.json on our local computer, but it'd be much nicer if we're saving it in S3 so that the rest of our organization can use it, and so that the rest of any other AWS services can also access it, right? So that's totally true. We will still be using Docker, right? Though, in fact, the last kind of lesson that we'll be going through in this unit is to Dockerize our Lambda function, whatever that is. All right, so we will probably by Sunday be reusing Docker in this context. All right. Other questions about this, and then we'll move on. But this was I feel like this was kind of confusing. So let me know if there's still some parts that feel a little unsure.
It's not better to use a volume over here in the Docker file because you're putting it on a
I think it really depends, what you want to, if you want to use the data in the context of Docker or not, if you want to then to only use this data when you're using Docker, then yeah, I would store this in a volume. But in this case, I want to get back the JSON and look at it. So I think it's fine, to just store it on my computer. Right? I just don't need the output. I just kind of want the output. I don't really need to have that output plug into a container. And in that, if that was the case, then I would certainly use volume. Okay. All right. Let's talk about the next thing. Give me 1 second. So that is basically back to our AWS pipeline stuff. All right. So remember, right? We compared our pipeline to how we originally worked, right? This is our new pipeline. We'll go through this in a second. This was our old pipeline. So meaning we're pipeline back from the first semester. So remember in our first semester, and maybe even more recent than that, right? We built this kind of client, Foursquare client, that hit an external API, coerced the data, stored it in a database, right? And then we deployed it. So then we deployed this thing to EC2, right? Just a computer. And then we connected it to an RDS instance. And basically the issue we said was, okay, well, we're always running this. Like the meter's always running, even when we're not using the database, even when we're not using our EC2 instance, we're still paying for it unless we pause it or terminate it, right? So we want to get away from that, or at least we can get away from that if we choose. So that's this new architecture. And instead what we did was we started by having our laptop hit the API. We're going to change this in a second, but we have the laptop make a request to this, we're using this receipts, the Texas drink receipts API. So we're hitting that API and we're storing a CSV file into S3. And we said one thing nice about, and then what we'll ultimately do is have Athena query our S3 bucket. So one thing very nice about this is we're separating the storage from the compute, okay? So we can store more and more data, and that's pretty cheap. What's generally expensive is the computing power, all right? So previously, remember, our instance was always running. As long as we were storing data in Postgres, this thing was basically on, and we're paying not only for the storage, but also for the CPU to keep this thing running and so that we can issue queries to our database. In this case, however, we're not really running Athena. We don't have to have this thing running. Instead, we just store our data in S3. This is very cheap because there's no CPU. It's just like storing stuff on a hard drive. And we can pay per query with Athena. So that's effectively what happens, is we just pay per transaction. And we don't have to pay for Athena like a dedicated Athena instance. We just pay per use. And for that reason, this can be cheaper if, say, we don't have a ton of queries. This can take a few seconds, right, running Athena. Like, this is the downside, is if you have users hit your API and they have to wait like 5 seconds or 3 seconds, that's generally too slow. But for some initial queries to say, all right, like pull down some data, maybe we only need a subset of the data, so we use Athena to search through our bucket. And then remember what happens is it will put the output in another bucket. So this is like our input bucket, and Athena will automatically store the results of a query in an output bucket, right? And we saw that towards the end of the last lecture. Okay, so what is the main benefit of this right here is that we're not paying for a database to always be running. We're paying per transaction, right? Per query. Okay. The downside is it's slower. We can't like perform as many optimizations. It's not actually like a database that you can like easily navigate that has like these many tables. It tries to. We talked a little bit about this data lake thing that Amazon kind of created, so that you can think of these different S3 buckets as connected as part of a database, and this data lake is like a wrapper around these various buckets. But yeah, it's slower, and we can't perform everything that we can with a normal Postgres database. All right.
Oh, so Jeff, yeah, just kind of ask your opinion about kind of another pattern like or AWS Aurora, like it's like a serverless database, kind of same spirit as like Athena and S3, like but in this case, S3 is not a database storage, right? So there's no index or other things but similarly, you can have serverless like database, like Amazon have like Aurora, like yeah. And I just wondering if you have any like opinion on this.
Yeah, I'd say this is good for like this pipeline is good for like this initial kind of storage with data where we're not really performing like we're just dumping the data in here and we're not cleaning it really at all beforehand. So generally you could, what you can do is like take the data, maybe select what you want and then move that into like a data warehouse, an analytics database. I'm honestly not super familiar with Aurora. I know like Redshift and Snowflake, but like this is good for just like some initial queries, initial like data exploration, right? And because you don't have to really coerce it or anything like that. You don't have to perform really any data transformations in order to start querying and exploring the data. Oh, cool. Very cool. All right. Okay, so what's next? So basically, so far we're moving to this pay per mile, right? I guess that's what I'm calling it. It's really pay per transaction model where we can store our data in S3. This is cheaper, and then we just pay every time we issue a query to S3. All right, and remember that data gets stored in our output bucket. The next step is, this request, like the actual hitting the API, storing it in our initial bucket. That's all happening from our laptop. That's not really a long-term solution. Like we want to have this in production. And previously what we did was we had this on an EC2 machine, right? We had our Python code on an EC2 machine, but we're back to this problem of our EC2 machine is always running and we're paying, even overnight when no one's using it, we're paying for it always to be running. The pay-as-you-go option here is a Lambda function, all right? And here it's the same thing. You pay per running of the function. So if we have a function, we basically wrap the main part of our code in something called Lambda handler. It's just a function, a Python function. And then we will call our requests.get and hit our API and get back a response and send that response to an S3 bucket, right? How often do we pay, what's the pricing model for this? It's per running of the function, okay? So you don't have to pay for a server always running. Instead, the pricing model is such that you just pay for each execution of the function. It's really two things. It's both you pay for, technically it's pay per use, and then you also pay depending on how long it takes to actually execute the function. All right, but if say I have a website, or say I'm only hitting the API once a day, it can be cheaper than just keeping this thing up and running and hardly ever using it, only using it once every 24 hours. Here I only pay for those one time that I actually use it. Okay, and also how much memory is allocated. Cool, so like how many resources. One thing to note, so this is called serverless, but it's kind of a lot. Like when I first heard the word serverless, because serverless means, to me, like, well, there's no computer. But this is on an EC2 instance. Like this is on still a computer. The difference is that you're not getting the whole computer, and it's really in the pricing model. You're not paying for this to just always be on. You're not paying for it to be running for every month. Instead, the pricing is pay per transaction. Okay, so that's how I think about it. Are Lambda and Athena two different services at AWS? Absolutely, right? Because Lambda is executing Python code, right? It's executing Python code. Athena is basically performing the function of a database and is querying your S3 storage. Okay, so I can show you this. So you can search, for Lambda. I guess I already have it up, and we can also search for Athena. Like they look, you'll kind of, I think you'll get a sense of it. So here, you can create a function. I'll just do like my sample. I'll just call it my new function. We'll say we'll author it from scratch, and then I'll choose a runtime. So this function can be written in JavaScript or Java. We'll obviously choose Python. The architecture, I generally just choose what matches my machine. Right now it doesn't matter. And ARM64 is like if you have a Mac M1 or M2. Then we can click Create Function. Okay, so you can see, right, this is lambda function.py, and this is what's going to be executed. All right, so we can just print like hello world, and we can put other stuff into here, right? We can do import requests, and then maybe like make a get requests. As long as I'm not sure if this library is there. I'm pretty sure it's there.
I think so. Yeah.
Yeah. What we'll have to do, every time you make a change to the Lambda function, you have to deploy it, all right? So I wonder if let's do the Texas drinks receipt API, see if I can get that quickly. Okay, yeah, this is fine. So this will be our URL. So we'll just make a request to this. And then we'll do request.get, and this will be my URL, and we'll make a get request to this, and then we'll get back a response, and then call response.json. This should return a list of dictionaries. Let's just get the first two. These are my receipts, and then we can print it just to make sure we see it, and then two, instead of json.dumps this, we can do json.dumps probably the receipts, unless I made a mistake. Yeah, okay. Yeah, exactly. We'll get into, so, Taylor's pointing out that, you kind of get some initial libraries. There are some libraries you do not get access to. One important one, like that just is not installed in here for you for free, is pandas. But we'll show how to work around that, or how to fix that. Okay, all right, so we are writing a function that is going to get executed, right? That can get executed for us. So what we need to do is we need to deploy this function onto, right, this like EC2 instance that Amazon is going to allocate a part of it for us. And then so I just click deploy, and it says successfully updated the new function, and then we can test it, all right? It's going to ask me to create a test event. An event is just like a dictionary that gets sent to the function. So we're going to execute the function, and you can pass through an event in the argument. So we'll create a new event. I'll call this sample event. You can see it's just like dictionary right here. It's just an argument that gets passed into the function. And we'll click save. And now I should be able to test it. Okay, and it broke. So it could not import the module name requests, but you can see it's trying to run this thing. So let's remove that. It's fine. It would have been more interesting, but no big deal. I think that should be fine. Let's deploy this again, and then let's run test again. What? I'm not using requests. Oh, here I am using it. Sorry, gang. Let's deploy it one more time. So every time I call test, it's calling my function for me. Okay, so this worked. All right, so you can see that the response was the status code 200, and the body was hello everyone. So it called my function and it ran this. Now this may seem very simple, but remember, basically all of our Python code is just functions that we're running. So if we want to say scrape a website, we can theoretically put our code base in here, right? And then just call, wrap the code that we want run. In this case, remember it was a save as JSON. Just wrap that in here and execute it, and it should run it, run that code. The other thing, kind of William was pointing out, was, okay, well, instead of saving this on a computer, we can then take that output and use the Bado library to store it in an S3 bucket. So even though it's just a function, well, you can, what it really is, what you can really think of it as like your main, this is like your main function that you would call. Yeah, it's okay. All right, so that's one thing. So okay, why is this powerful? One, you pay as you go. So as your website scales up, like as more and more visitors come to the website, you don't have to worry really about this crashing. You'll just pay more money essentially, and eventually, if it becomes too expensive, you could move to EC2. But it's nice that this auto scales for you. Another thing that's nice about this that we'll see is we can, like here we're using a test event to trigger the execution of this function, but there's other things we can do. Like for example, we can schedule this thing to be run every hour, every minute, right? And that and that will maybe scrape a website every hour, every minute. We can say every time that something's uploaded to an S3 bucket, we can run this function, right? So whenever someone uploads some data, we can clean it and trigger this function to process it and then send the clean data to a different bucket, something like that. So this is kind of like, because it responds to events, we can use like a series of events to build a real pipeline. So to kind of start to show you that, you can see like what we'll do is, we can trigger our Lambda function, which will hit the API, and then which will use the Bado library to store some data in S3, right? And then we could even perhaps have a Lambda function that watches to see when this is uploaded, when an object gets added to our S3 bucket, to then run Athena code to query the bucket and store the output results, something like that. So we'll start building more complicated pipelines. But what Lambda does is it can just execute a function for us. Remember, right, this can become pretty powerful. What Athena does is it queries a bucket for us, like it doesn't respond to events. Like it doesn't I guess you can do some limited kind of scheduling of events, I think, with it, but really, like this thing responds to different actions that occur in AWS. This Lambda function. So for instance, like I said, uploading data to an S3 bucket. Another one is you can effectively build an API. Someone can make a request, and that request gets sent to your Lambda function, right? So there are various kind of actions that can trigger this, and you can see them here with this add trigger. You can see the select source. This API gateway is a website. Someone can hit this, make a request to this. It gets sent to your Lambda function. We'll see S3, right? But there's these various services in AWS, and then there's also all these other things. So that can trigger your Lambda function. So it's pretty interesting how you can say, okay, when this happens, right away, perform this process.
The Lambda function always defined with the handler, like you defined as like Lambda underscore handler, the name given.
Yeah, that is the default. Like, there's no reason really to change it, but let me just show you what it does. That's defined down here. You see it says handler, Lambda function, Lambda handler. This is like AWS needs to know what function to run when an event triggers it. So when it receives an event, here it's saying, go to the Lambda function module and execute the Lambda handler function inside of that. You can change that here, right? But if you look at it, we have a Lambda function module, and then we have a Lambda handler function. So that's what it's going to call.
Okay, and what about the event and context? Is this an object passing through parameters?
These are two dictionaries. So
okay.
The event is this event in this case, right? It might be different events. So uploading something to an S3 bucket will send an event that has certain information about like what bucket was uploaded to, what was the object name, things like that. This test event, right, just has, can I see it? It was just a dictionary. So in all cases, it's just going to be a dictionary. And you can print it out. And the context is kind of like I haven't used it too much. It's basically metadata about the event. So it would include things like the timestamp as to when it was called, things like that. All right. One kind of confusing thing is sometimes seeing this return value is not always super explicit. To see like an event being executed, what you can do, let me see. Okay, there's a thing, this panel monitor, right? And this takes you to another AWS service called CloudWatch Logs. It's just a logging service, right? It's just logging, right? The same way you saw logs with your Flask application. You can click on the log stream, and this will show you just this, like, again, like the Flask application, it shows you your application being run, right? You can see like start requests. It shows you, I guess these are the request IDs. It's not showing you the output. It's not showing you the return value. All it shows you is like the printing of it. So if you want to see something, the easiest way, at least for me, is just, go to the function, print it. So we can like print the context, print the event, and say, okay, here's the event, here's the context, right? Deploy it. That's wrong. Yeah, that's okay. All right, and then deploy it, right? Because we updated it. We need to like kind of save our changes, and then you can run a test event. And you can see here we're printing out the event, and here we're also printing out the Lambda context right here. So you can see it has, a request ID that I guess you can use, and how much the memory limit was that you were allocated for this. And if you go to the monitoring panel, one thing a little annoying, sometimes it's a little hard to find this. I generally look, okay, this is the log stream. Oh, sorry about that. Let's go back. Monitor. We can also click on View CloudWatch logs. So this is June 1st. And then here's the timestamp of when this file was created. So this is more recent. It seems like 6 o'clock. Oh, it's 7. I'm not sure. Probably this one. Let's see. Yeah, I actually don't see the event. Because that event should have also been printed out. I might be looking at the wrong one. 1, 2, 3, 4. Unless this was it. I think generally this would be, it's a military time, right? So I think it would be this one. But I'm not sure. Let's see if this makes it any more clear. If I go to the CloudWatch logs. Okay, here's a log stream. This is the most recent one, 7/14, right? And then let's click on this log stream. Okay, and here you can see it, right? Here's that event getting printed out, and then here's the context getting printed out, right? So this is when we ran the function, it logged that, it printed this content out, and then it ended the request. All right, so this is it's a nice way to see that your Lambda function actually triggered, to see, if you want to print out any values and try to debug it, right, you can do that here. Okay, so the way that I did that, again, it was just going to monitor, and then you can go to View CloudWatch logs, and then you generally click on the most recent one. And there might be more than one event in there, so you might have to scroll down and look, or click retry to load, to just update this stream. Okay. All right. So again, and just to review, Lambda functions, right, respond to events. You can send various events that trigger them. Our Athena is something like we are using to query our bucket, right? We're not like there's no lambda. Lambda is just a function that gets run. It's kind of like you illustrate whatever you want inside of it. Athena is a specific service for, okay, let's run a statement, run a query, in Athena. Now what we could do is we could, and eventually we will do this, have our Lambda function connect to Athena through Bado, right? We can like import Bado up here and then say, okay, use Bado to connect to like Athena, and then call some sort of Athena function to query our S3, get query result, I forget what it's called, and query the S3 bucket. So we'll eventually do something like that. But to directly get, execute a SQL query against our S3 bucket, we need to use Athena for that. All right. Okay. Let me stop. Oh, other questions? All right, then I'll stop talking.